Okay, one alpha, good morning. Can you hear my voice?
Yes, good morning.
Okay, thank you. Make sure you can hear my voice loud and clear without any noise or interference. Got interference, some like noisy things, noisy sound, or just
No, no.
clear? Okay, okay, very good. Thank you, Kaini, and thank you, all of you, of giving your response. Okay. Also, now I will try to share my screen. Yeah, I will try to share my screen first. Okay, again, can you see my screen sharing?
Yes.
Okay, very good. Thank you very much. Okay, so how many of you today? 20. Okay, most of you came come. Okay, never mind. How do you do today? Everything is okay? You have any problem at home? Hmm?
No.
No, make sure you stay healthy. Make sure you stay healthy and stay at home. Yeah. Although we are in a phase two, according to the government, we are on the phase two, phase two state. There is a bit of what we call relief on the MCO, right? For those who are already get their full complete dose, first dose and second dose of vaccine can travel between district. But for the time being right now, it is better for us to stay at home if we do not have any what we call business to do outside. We just stay at home only. Because Sungai Siput also the cases are increasing, like I said earlier, like I said many times. Um, you know previous on our previous classes, but never mind, just stay at home and stay healthy. If you have any problem, please contact the teachers. Tell you can ask the counselor, and and then your parents also. Okay, don't worry. You have any problem, you can ask me. Ask the teachers. Okay, we are here to help you, not just in education, not just in learning in school, but anything else. Okay, we are trying to help if you have any question, if you have any problem. Okay, class. Right. So that is the number one. I hope you are in good condition and stay healthy. If you have fever, and go to the nearest clinic. And then I heard our hospital Sungai Siput is already closed. You know about this? The hospital Sungai Siput is already closed because it turned into COVID hospital. So if you have any, I don't know about the emergency department, but if you have fever or whatever, you need to go to others clinic, not to hospital Sungai Siput, because hospital Sungai Siput is already converted into COVID hospital. There are COVID patients in hospital Sungai Siput. You know, do you know about this? Do you know about this?
Yes.
You know, right? If you want to go to the clinic, you can go to the nearest clinic lah. At Jalong you got the clinic. At the Lintang also we have the small clinic over there. Please do not go to the Sungai Siput Hospital because it already closed. Closed because of the COVID lah. It will COVID patient at Sungai Siput. Right. So that is the second matter. And then the third matter, yesterday announcement, it is about the reopening of the school. Reopening of the school. And then, if you can see my presentation right now, the actual plan to open the school is on 1st September 2021. Okay, but due to the uncertainty of these cases of COVID, so they extend the reopening of the school until what class? Who know? Until 3rd of October 2021. Okay, so there will be no reopening of school at 1st September. So, sorry. they will extend the plan to reopen the school at 3rd October. Yeah, 3rd October 2021. All right. So you have another how many weeks? 1, 2, 3, 4, 5, 6, 7. You have another 7 week, 7 week, 7 or 6 week PDPR, meaning that learning from home. All right, until 3rd of October. School holiday on September will start on 11 to 19 of September. 11 to 19 September is our school holiday. All right. And then depend on the cases lah, depend on the situation. If every what we call teachers, every adult has been vaccinated, COVID vaccine, and then the cases increase, maybe the school will be reopened on 4 lah, on 3 or 4 October 2021. So we'll be doing PDPR, we'll be doing the learning from home for another 6 weeks. Right, class? You understand this? Is it okay?
Okay.
Okay. That is the current situation right now lah. Before I start the class, I need to give you some information lah. So I hope again, be prepared mentally, emotionally, and physically. Okay. I know because the what we call online classes, learning at home is not is challenging. It's very hard for you and also very hard for teachers like me also. Okay, but what to do? Because of this pandemic of the COVID, okay, we need to stay healthy. School can be closed. Okay, never mind. We can learn at home. But the most important thing right here is our health. Our health, you must be in good condition. We can learn at home. Never mind. Let the school close. Let the situation of this COVID pandemic settle down. Then maybe one day, maybe end of the year, okay, we can see you all again back in school, right? So you must be strong. We must be strong in order to face the pandemic, the challenge, the COVID over here, right? Okay. All right. So we continue our lesson for today. Can we continue our lesson for today, class? Is it okay?
Yeah.
Okay. So our previous lesson, we already learned about 8.4, the reflection or what? The reflection or refraction. The refraction of light, not 8.3. Our previous lesson is 8.4, the refraction of light, refraction of light. And then I already give you the exercise for you to do, formative practice 8.4, and then workbook page 77 to 78. Is there any problem with our workbook exercise? Any problem? About 8.4, page 77. I think page 77. The refraction, 77 to 78. Any problem? Do you understand about the what we call by refraction of light?
Yes.
Okay. Do you have any problem? No?
No problem.
Okay, if you not a problem, so I think we can go to next topic for today. We go to the next topic for chapter number 8. This is what we call the dispersion of light. All right, dispersion of light. So how many properties you already learned? We start from 8.1. Okay, we just for chapter 8, chapter 8. Okay, for chapter 8, so we have 8.1 is mirror, isn't it? 8.2 and then 8.3, 8.4. Okay, our last chapter is 8.4. We learn about the refraction of light. 8.3, we learn about reflection. And then 8.2, we learn about the properties of light. Properties of light. And then reflection of light. And then 8.4, the refraction of light. And then today, 8.5, you learn about the dispersion. Okay, make sure you understand this. 8.3, 8.4, and 8.5, reflection, refraction, and dispersion. Okay, so today until 8.5, dispersion of light. Okay, what is a reflection? You just remember, we are just using a plane mirror. And then at the middle, we have normal line. And then we have the, what we call this? The first line, we call it, what type of light is this? This is what we call by incident. Yes, incident ray. And then this is what we call by reflection ray. And then I. Incident ray is I. And then reflection ray is R. So this is the what we call the angle of reflection ray for reflection. For the light refraction, I is equal to R. Okay, this is for what we call reflection of light. Yeah. Okay. Still remember? Okay, so reflection is very easy. And then how about refraction? Refraction, R-E-F-A-C-T-I-O-N. Refraction, if you still remember, refraction is when the lights travel to different medium. Okay, for example, we have here what we call a block. Okay, a block of what we call glass, for example. Okay, so this is what we call the glass block. This is the glass block, for example. Okay, and then this is normal line, for example. Normal line is exactly how many degree normal line? Normal line over here, this is what we call by normal line. Okay, all right. And then if we can draw the ray, the incident ray, like this, and then what happened? What happened to the light inside there? It will bend. Okay, it will bend near the normal line, like this, and then it will go back here. Okay, so this is the incident, what we call angle, and then this is what we call refraction angle. Okay, I is the incident angle, and then R is refraction angle. Not angle, sorry. Not angle. Angle is malaikat. Sorry. Not angle. Angle, not angel. This one. Angle. right? Okay, but usually the incident angle and the refraction angle over here is different. For example, if the reflection angle, the incident angle is about 60 degree. So usually the refraction angle will be maybe about 50, um, 50, for example, 58 degree. For example here, because depend on the medium. Glass block different density, water different density. Okay, because of the different density, the refraction angle also different. All right, I already give you the link for you to play with the simulation of refraction of light, and then you can what we call try to explore it yourself lah, the refraction of light. Okay, right. So next one, what happened to the pen here? Okay. All right, now the dispersion of light. Okay, so what is the dispersion of light? 8.5. Okay, so you must remember number one, right? Point number one, white light is consists of 7 component of color. Okay, you just remember it. 8.5, white color, okay, consists of the white color consists of 7 component of color. When you mix all the 7 color of light, it will become white. Okay, and then number 2, each component of color travel at different speed in medium. Okay, meaning that each color of light travel or got the different speed when it travel through a medium. The medium here is what, class? What is the medium here? We already learned. The medium here may be through air, and then through solid, and then through gas. And then through liquid. Okay, do you still remember the refraction when the lights travel from air to water, for example? That is the medium. Medium is the substance which has different density, such as water, such as a glass block, such as gas. Okay, so each of the color will travel at different speed. For example here, red has the highest speed, so red is the refracted the least. Red has the highest speed, so it has refracted the least. And then, however, the violet light has the lowest speed, so the violet light is refracted the most. Okay, this is what we call by the what we call the component of the white light. Okay, can you understand this, class? Never mind. Later on, we try to go one by one. What is the meaning of the speed of light, and then what are the 7 components of color inside the white light? Okay, next one. Okay, so we can what we call demonstrate the 7 component of color by using a glass prism. Okay, so if you use the glass prism, when a white ray is directed to a prism, the white light will be separated into component of color. This is because the different color in the white light bends toward the normal at different angles when entering the prism. Okay, right, you can see here, this is what we call a glass prism. Okay, I will try to wait, class, I need to okay, right. Okay, never mind. Okay. All right, glass. So this is example of what we call by glass prism. Yeah? Glass prism. This is glass prism. Okay. Glass prism is what? Is what we call solid, liquid, or gas. What is the condition of glass prism? Glass? Solid, liquid, or gas?
Solid.
Solid, right? Okay, solid. So what is the picture of the glass prism? Okay, this is the picture of glass prism. Okay, this is glass prism. Okay, this is what we call by glass prism. All right, just a piece of glass in the shape of prism. Okay, right. If I use, okay, if I use just what we call glass block, for example, I use the glass block over here. Okay, if I just use the glass block, this is glass block. Okay, if I what we call use white light. Okay, for example, I take the first what we call the light over here. This is what we call by the incident ray, right? If I use the white light as incident ray, what will happen when the lights travel into the glass block? It will what happened to the light inside? It will
Bend.
bend. Very good. Okay, it will bend. Okay, so if I use white light, for the incident ray, the light inside the glass block is also what? It's also white or other color?
White.
Also white. Very good. Okay, and then what is the light produced when exit the glass block? So what is the color of light? This also white color, and then this also white color. Okay, why? Because I'm using the glass block over here. Okay, glass block, if I use the white light, when the white light enter the glass block, it's still white. It doesn't separate into 7 component of color. When the white light exit the glass block, it also white. Also white light exit the block. Okay, why this happen? Because the thickness of the glass block is same. Thickness here same. You can see the thickness is the same. So the refraction rate is also the same. Okay, this one also, if you can see here, when the light enter the glass box, the thickness same. And then when the light exit the glass block, the thickness also same. So you cannot see the 7 component of color by using glass block. By just using glass block, you cannot see the component of color. White light enter, the white light refract inside the glass block, and then also when the white light exit the glass block, it also white in color. Okay, that's why we use what we call glass prism. We use glass prism. For example, if I use the same what we call line here for the ray, okay, so this is the same line. Okay, never mind lah. I just use the thicker line over here. Okay. So this is the incident white light, white light. Okay, this is white light enter the prism, and then what happened here? It will what happened to the light? What happened to the white light here? The white light will be refracted, or will be what we call disperse. Will be refracted and then it will be dispersed into how many? 1, 2, how many color? How many color class? It will disperse into
7.
Yes, it will disperse into 7 color. Okay, there is a refraction going on here, and then also there is a dispersion going on. Dispersion mean the white lights become, it can be separate into 7 color. This is dispersion. Okay, refraction. Refraction is just the bending of light. Okay, the bending of light is the refraction. So in this 8.5, we have two process here. One is dispersion and then one is the refraction. Okay, if you can see here, the lights travel inside the prism is bending, also bending. Yeah, all right. And then if you're using glass prism, it is not just bending the light, but it is also disperse the light. Disperse the light into how many color? Disperse the light into 7 color. Okay, it will disperse the light into 7 color. Okay, so what is the color? Okay, why it will disperse the glass into 7 color? I use the blue pen over here because you can see the thickness of the prism over here. The thickness at the top. What is the thickness? Which glass block over here, which has the highest thickness? Number at A or at B? Which has the highest thickness? A or B? The thickness, the thickness of the what we call glass, the thickness of the glass at A or at B?
B.
B, yeah. Because this is why how we can separate the white light into 7 color, because there is a different thickness. Okay, B has the highest thickness. You can see over here, yeah? It has the highest thickness, and then A has the lowest thickness. Okay, if you refer back to the thickness of the glass block, same or different? For example, here at number C and D, same thickness or different thickness at glass block when you are using glass block? Over here, class. C and D over here. C and D, same thickness or different thickness?
Same thickness.
Same thickness, yeah. If same thickness, you cannot separate the white light into 7 color. But if that's why we use glass prism. We use glass prism because of the difference of the thickness, okay? And then you know that the color that refract the most is the violet. So number 7 is violet. And then the color that refract the less is red. You can see here, it will refract the less. The number red, color red, and then color violet, it will refract the most. Because why? Because the speed of light, and then because the medium, the light travel in the medium. Okay, thickness glass, meaning that if the light need to travel into the what we call the highest thickness of the glass, it will travel slower, so it will disperse into color violet color. Right? Can you understand how the formation of the rainbow, how we try to separate the white color into 7 component of color? Okay, red has the highest speed of light, and then the violet has the the slowest speed of light. The violet will refract the most, and then the red color will refract the less. Okay, again. All right. Okay. Do you understand this? Right? So you must you must remember. Thank you for your response. You must remember the 7 spectrum of color. Okay? Must remember 7 spectrum of color. We start from the red, and then orange, and then yellow, and then green, and then what else? Red, orange, yellow, green, blue. Okay, blue, indigo, and violet. Can you remember the 7 component of color? Okay, you need to try to memorize this 7 component of color, yeah? From red to violet. Okay. Which color of light refract the most? Violet will refract the most, and then red color will refract the less. Okay, because why? Because of the thickness of the glass over here. You can see the thickness here. Thickness. This is what we call the thickness one. Thickness of a glass. Okay, number 1 over here has the lowest thickness, and then the glass over here, glass number 2, parts number 2, it has the this is lowest, the lower thickness of glass, and then number 2 has the highest thickness. Okay, that's why we can separate the component into 7 color. Okay, class. Is it okay?
Okay.
All right. Okay, this is what we call a spectrum. Yeah, the 7 color the light dispersed from the white color. The 7 color of the component of white color, we call it a spectrum. Okay, you must try to remember or memorize the spectrum of color starting from red, orange, yellow, green, blue, indigo, and violet. Okay, which color refract the most? Violet. Which color refract the less? Red color. Okay. All right. Okay. So next one, the formation of rainbow is the example of natural phenomena that occur in the refraction and the dispersion of light. This is how we see the rainbow. Usually, when do you see the rainbow? When do you saw the rainbow? Usually, when there is what?
After.
Okay, after, during the rain or after the rain, right? During the rain, you can see the rainbow. Because the rainbow, we can see 7 color of the rainbow because the white color refracted by what? Refracted by what?
A drop.
Okay, very good. Will be refracted by the droplets of rain. Okay, the droplets of water will what we call disperse the white light from the sun. Okay, there is an activity here, but I cannot show you the activity later on. Later. Okay. For example, I try to copy the droplets of water first. Droplets of water. Okay, for example, over here. So this is the example of droplet of water. Okay, the formation of rainbow. Copy image. Okay, for example, this is the droplet of water, just one drop of water. Okay, just one drop of water. Just an example, just to show you the example only. Yeah. So we have here a droplet of water, just one droplet of water. Okay. During the rain, there are not just one droplet of water, right, class? During the rain, there are million. We cannot count the droplet of water lah during the rain, right? So this is the typical shape of one droplets of water. Okay. So when there is light coming, for example, this is the light from the where? The white light from where? White light. This is from the sun. Okay, the white light come from the sun. You will refracted. The light will be refracted inside the droplets of water. So what happened to the light, the white light inside the droplets of water? It will what? What happened when it enter the droplets of water? Number one, it will be refracted. And then number two, it will disperse. Okay. So then it will disperse into how many color? How many color? 7 color of white light. We call it spectrum. We call it a spectrum. Okay. Why the white color can disperse into 7 spectrum of color? This is because of the shape of the droplets, right? If you can see the upper here, the thickness of the droplet is at A. This one is A, and then this is B. Can you see the difference in thickness of droplets of water? Which one has the lowest thickness? A or B? A or B has the lowest thickness? A, right? A. Okay, A has the what we call the less thick, right? Less thick, right? And then at B, thicker. So that because of the difference of the thickness of the droplets of water, so it will disperse into 7 color of spectrum. Okay, again, you must try to remember. You must try to remember the 7 color of the spectrum. That is number 1. I didn't draw. I didn't draw carefully, but you must remember the first one is red. Number 2, class. Ayo, forgot. Number 2. You must remember lah. Okay. Number 2 is orange. Orange. Number 3 is yellow. Number 4 is green, right? Green. Number 5 is blue.
Blue.
Yes, good. Number 6 is indigo. And then the last one is violet. Yes, purple or violet. Violet, because indigo and violet, if you can see here, is you cannot call it purple lah. You call it violet, or maybe purple. But according to the textbook, you need to name the color violet, right? Violet. So this is how the formation of rainbow. The formation of rainbow. Because of the shape of the droplet of water, right? This is the thicker side of droplets of water at B, and then at A we have less thick, the thickness of the water at A is less. So when the white light enter the droplets of water, it will disperse into 7 type of color. We call it spectrum, the spectrum of color. Okay, which color refract the most is violet. It will refract the most. it will bend the most. Can you see here? It will bend the most. What I mean by bend the most, you can see here, it will bend the most. For example, this one lah, it will bend the most. If you look at the angle here, it will bend the most. Violet. Which bend the less? Bend the less is the red color. The red color here bend the less. Violet color bend the most. Because of the difference in speed, and then also the thickness of the droplet of water. Okay, that makes the white light bend, right? Okay, right. Sorry, I got the call. Okay, any question before we stop here?
No.
No question, yeah? Okay. All right. So if you have any question, you can ask me to the through the Telegram. I will give you the exercise later on, yeah, after this class. So any other things? Make sure you do my my works, and then we see you all again on tomorrow lah. Tomorrow we have class at 8:30 in the, not 8:30, at 9 a.m. in the morning tomorrow. Okay, if you have nothing to ask, you can leave the class now. See you all again tomorrow. Okay, class? Okay, you can leave the class now. Bye-bye.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you.